Hey all, as you can see, I'm trying something new today. I'm not recording using the board, so you can see me, a little at least, my hands. We're going to talk about similar polygons in this lesson. And in order for two polygons to be similar, they need to meet two different conditions. Number one, they need to have corresponding angles that are congruent. Remember that we can determine which angles are corresponding by looking at the names of the polygons. And the corresponding sides need to be in proportion. And that's an important word. We talked about proportions last class when we did the review. And that means that if we write a ratio or a fraction of the corresponding sides, all those fractions will be equal to each other, and we call that the scale factor. So here's an example of two similar triangles. We can first look at their angles. I see that I have one pair of angles that each have one arc, so they're congruent, and they correspond, A and X in the names. I see that B and Y, those are also corresponding angles. They're congruent because they're both right angles. C and Z, they also correspond looking at the name, and they have the two arcs here, so that means they're congruent. So I have three corresponding angle pairs that are congruent. And just really quickly, this symbol right here, just a little squiggly, looks like what we put on top to make the congruent symbol. This means similar. So that's our symbol for similar. Now we need to check to see that the corresponding sides are in proportion, which means they're the same fraction. So let's look at side AB and XY because they correspond. We can write a fraction. We'll just do big to small, which means we'll put the big on top. We'll do the same thing for BC and YZ, big over small. And lastly, we'll do the same thing for AC and XZ. I'll put the big over the small. Now sometimes you'll be asked to write a ratio from big to small or small to big, and that'll just tell you which number to put on top. I went from big to small, so my big number was on top. Now in order for these to be in proportion, when I simplify all of them, they need to be the same fraction. So 15 over 6, we can divide both of those by 3, and I get 5 over 2. 20 over 8, we can multiply both of those by 4, and I get 5 over 2. I'm sorry, I said multiply, I meant divide. 25 over 10, we can divide both of those by 5, and I get 5 over 2. So you can see that the proportions, the fractions are in proportion, meaning they all simplified to be the same thing. So if we know that two polygons are similar, then we can use the relationships or the conditions to find values of x. So I know these triangles FGH and MNP are similar. And I see that I have sides labeled. So I can use the knowledge that the sides should be in proportion to write a proportion, solve it, and find x. So side MN corresponds to side FG. So I can write FG over MN, 12 over x. And then I'm going to need to use NP. So the side that corresponds to NP is GH, which is 20. And since I put the side from the bigger triangle on top in my first fraction, I'm going to do the same thing for this one. So I do 20 over 10. And now I'm solving for x. I cross multiply. 12 times 10 gives me 120. X times 20 gives me 20x. And I just need to divide both sides by 20 to get x. And I get that x is 6. So I want you to go ahead and pause here, and I want you to find x in these similar polygons. So here, these polygons are in the same orientation, so I can see this side that's labeled x relates to this side that's labeled 12. So I'm going to write a fraction 12 over x. And then I only have this side labeled 9 in this polygon, so I'll write 9 over the corresponding side, which is 6. And now I can solve this proportion. I get 9x equals 72. I'll divide both sides by 9, and I get that x is 8. So I have one you-do problem for you. Triangle ABC here is similar to triangle DEC, and I want you to find the value of x, and then of course we can talk about it in class.